Okay guys, I'm going to walk through practice problem number 1 for you. You'll see that the formulas aren't as hard as they look. They're just a little tedious and you have to keep all of your work very organized. So the first part of this I have laid out already because I know that's pretty simple for you. So in step 1, the null hypothesis, we're simply testing that all of the means are equal to each other. The alternative hypothesis is going to state that at least one mean is different from the others. And that's where our claim is going to go. In number 2, our alpha is given to us to be at 0.05 level. So then 3, I calculated my critical value. So I'm still using that F distribution chart, so I need to know what the degrees of freedom of my numerator is and the degrees of freedom of my denominator. So for my numerator, I have to take the number of categories minus 1. Since I have 3 different categories minus 1, that means the degrees of freedom of my numerator are going to be 2. And then the degrees of freedom of my denominator becomes capital N. And capital N is the total number in all 3 samples added together, minus the number of categories. So there were 24 items in all 3 categories, minus the 3 categories gives me a degrees of freedom for my denominator to be 21. From there, I look at my F distribution in the chart that is labeled 0.05, with my degrees of freedom of my numerator being 2 and my denominator being 21. That gave me a critical value of 3.47. So we should reject any value of F that's greater than 3.47. All right, so now comes our calculation of our F value. So for our F value, we're going to need the MSB, which is between the factors, and MSW, which is within the factors. So what I've gone ahead and done is I've done everything in a Google Sheets document so that I had everything ready and organized. So I put all 3 categories into lists, and then from there, I calculated the mean of each list separately. I calculated the standard deviation, and there's a lot of choices for standard deviation, so you want to choose the one that gives you the standard deviation for a sample. And I had the sheets do the calculation for the first column, and then I drug it over and let it do the other 2 columns. Then I forgot that I actually needed the variance. So you really need to take that standard deviation and square it. So I just did that by hand. You can let the Google Sheets do that for you. I'm sure there's a variance function in there. Or you just take your standard deviation and you square it. All right. One other calculation I knew I was going to need. knew I was going to need the grand mean. So I quickly did a calculation where I took the sum of all 3 columns and I divided it by my 24 because there's 24 items in the total sample, and that gave me a grand mean of 1.205. Then I go to that F formula that looks really difficult, but if you break it up in pieces, it's not really that difficult. So the first thing I'm going to focus on is that SS sub B. So I'm looking at taking each mean and comparing it to the overall mean. So that's not too difficult. We've done that many times this year. So I'm going to work on this first piece at the top first. We're going to break this down. So SS sub B is going to be the sum of each individual sample size. So my first sample, I had 10 items. And I'm going to take that times the mean of sample 1. Now I'm just getting that right from this chart. So I'm going to do 1.192 minus the grand mean of 1.2. So I'm going to mark that down, 1.192 minus the grand mean, and then square that difference. And I'm going to do that again for column 2. In column 2, the mean is 1.026 minus the grand mean. And then column 3, I only have 4 pieces of data in the 3rd column. And the mean of my 3rd column was 1.6875 minus the grand mean of 1.2. Now, once I do that entire calculation, that's my SSB. That's the difference between my means of all of my samples. I get a value of 1.254. So now what I have to do is calculate my MS sub B. That is going to take that and divide it by the degrees of freedom of my numerator, which we've already calculated to be 2. So now I'm going to hold on to this number. This number is going to give me about 0.627 because I did a lot of rounding along the way, and I'm going to hold on to that number. From there, now I'm going to work on the numerator piece, or the denominator. So I'm going to chunk this and only look at this piece first. So what I'm going to do is take the degrees of freedom of each column times its variance. That's all I need to do here. And then I'll worry about that divided by n minus k afterwards. So in the first column, I have 10 things in my sample. So I'm going to make that 9 times, again, I'm using the variance. So if you've calculated that standard deviation, you want to square that number right here. Or if you've already squared it, don't square it again. Plus, there's 10 minus 1 gives me 9 values in my column 2 times its variance, plus 3 items in my third times its variance. When I calculate this out, this gives me a value of approximately 17.0661, but I have to divide that by the degrees of freedom of my denominator, which I've already calculated out to be 21, gives me approximately 0.813. Now I'm almost done now. Now I'm ready to calculate what that actual F value is. So my F value is taking MS sub B between MS within, those are my standard deviations, and dividing those out. So that's going to give me 0.627 divided by 0.813, and since this is a lot of rounding, I'm going to say it's approximately 0.7712. Now, if I go back to the top up here, I can see that I was supposed to reject if I'm greater, which I am not. So that means in step 7, I'm going to fail to reject my null hypothesis, and therefore I do not have enough information to conclude that at least one mean is different from the others, and there'll be a chance of a type 2 error at the 0.05 level.